Alright, welcome back, Honors Algebra 2. Today we're going to talk about Cramer's rule. Cramer's rule is basically a rule that you can use, it's a little formula that you can use to solve linear systems, either 2x2 or 3x3 or anything actually. It's actually probably, once you get the hang of it, a little easier than doing linear combination or substitution, especially when the numbers get really bad. We use Cramer's rule to help us with ones that would give us fractions or decimals. So let's just talk about this. First of all, when we work with Cramer's rule, we want the determinant form of the line, we want it to be in the form of ax plus by equals c, which you guys should recognize as standard form also, okay? So we want it, it doesn't have to be negative, don't worry about the rules for standard form though. You just need it to be set up like that. So evaluating a determinant comes from a square matrix. It's a value that's associated with it. For a 2x2, I did that wrong actually. It should be A, B across the top and then C and D. So if I have a matrix that is like that, the determinant, and you would see determinant written as, it looks like a big absolute value symbol actually, as that. And to evaluate a determinant by hand, you multiply down first, so A times D, that's the first part. So it would be A times D, and then you subtract it from C times B. That would be how you evaluate that determinant. You should get one value. A determinant always gives you a number. Okay? We use determinants to solve our answer. So let's say I have a system of equations right here. Ax plus by equals E, some letter. And then I have another equation, cx plus dy is equal to f. So these are my two ones. Usually there's numbers where the letters are. You first have to get the d determinant, which we would call the denominator determinant. The d determinant is your base determinant. This is one you're always going to use. It's just the four letters in front of the letters. So it's the one we just did up above, a, b, c, d. Okay? The next thing we do is we find the n sub x determinant. Now notice I said n sub x. Well, remember, these are the ones that are associated with the x values, these are the ones that are associated with the y values. Instead of the x values, we are subbing in e and f in this one, so the numbers on the side. And then we're going to do b and d again. Finally, we have to find n sub y to take care of our y coordinate. So we go back to A and C is the same, but now we're subbing in E and F for the y coordinates. Okay? And I know this looks very confusing right now, so just bear with me. Once we start working with it, with the actual problems, you'll see how easy it can be. I'm also going to show you how to get the determinant on the calculator. Alright, so to find your x coordinate is equal to the n sub x number over the d number. Your y coordinate is n sub y over d. And then you have your answer, x equals this, y equals that. And you'd be done with the problem. Alright, so get that down. I know it's a lot of letters, a lot of confusion. That's what's supposed to happen initially. And now let's talk about how to do it with the problem. Again, first, solve using Cramer's rule, show all setups. The thing I need to see from you guys while I'm using Cramer's rule is I need to see the d matrix or determinant, the n sub x determinant, and the n sub y determinant. And then what you get for those, and then the answer. So, show all setup. First off, we have to get it into the correct form. Notice how this is not x and y and then a number. Neither is this. Move your x this way, move the 5 this way. So, this is going to turn into 4x plus 9y equals negative 5. I'm going to move the 27y this way and the 15 that way. So I have 10x plus 27y, or sorry, minus 27y equal to 15. Alright, so now we have those two things. And we can now set up our determinants, just using the format that I did up above. So the first thing you want is your d determinant. The d determinant are just the coefficients in front of your x's and y's. So 4, 9, 10, and negative 27. Now, you can do this by hand, where you multiply these two together and then subtract 90 from it, because it's 4 times negative 27, which is 108, minus 10 times 9, which is 90. And you should get that this determinant is negative 198. And again, that's 4 times negative 27 minus 9 times 10. That's how you got the determinant. And for 2 by 2, it's really quick just to do that. You can use your calculator to get the determinants also. I'll show you that if we have time today. Now I need the n sub x determinant. So I got one number. Now I need the n sub x. Again, for n sub x, you take away the x coefficients, 4 and 10, and instead replace them with the numbers negative 5 and 15. You keep the y's the same. You're only subbing out the x's. Alright, now we calculate this. When you multiply negative 5 times 27, oh, I made a mistake. This should be a negative 27 because it's negative here. So just be careful when you're writing down your numbers, because that will change the whole problem. Negative 5 times negative 27, and then minus, so that'll be positive, but minus 9 times 15. You guys should get that that will equal 0. Because 5 and 27 is the same thing as 9 times 15, which is what, 145? Yeah. So, or 135 actually. 135 minus 135. And finally, we have to do n sub y. So I set it up the same way, except for now my x's come back. So you always start back at this first d determinant. 4, 10, 9, negative 27. So we're back to 4, 10, but instead of 9 and negative 27, I'm subbing out the y values and putting in a negative 5 and a 15. And when I calculate my determinant here, you get 60 minus 50. I'm sorry, minus a negative 50. So 60 minus a negative 50, and you should get a positive 110. Okay? So those are your three determinants. And then finally, to get our coordinates, x equals 0 over 198. It's n sub x over d. And y equals 110 over 198. And I should be putting negatives with my 198s. Which, when you simplify, is negative 5/9. So the solution to this system is 0, negative 5/9. And we're done. Okay, we just use determinants, find the three different determinants, and then it's n sub x over d, n sub y over d, and those are your 2 points. And you're done. Alright, let's try it again. Again, pause on the screen if you need to look something up. On this one, maybe I'll show you guys how to do it with a calculator, but we'll see. First off, we have to set these up so they're okay. The first one looks okay. The second one does not. So I'm going to just rewrite the first one. Move the 10y over. And yes, you can solve these the other ways too. So if you're looking at this and going, this will be really easy to do by elimination, yeah, that's true. But I want to show you how to do it this way, because on the test or quiz, it'll ask you to solve it a specific way, and you have to follow the directions. So you have to understand how to use each tool we have here. So if you guys want, try to write down your three determinants before I do. Pause the screen, see if you get them. Okay. First one though, we always just start with the coordinates, or the coefficients in front of the x's and y's. 8, 5, 16, and 10. Well, 8 times 10 is 80, minus 16 times 5, which is also 80, so d is 0. N sub x. We put, instead of 8 and 16, which were our x's, we put the numbers in now. Negative 7, negative 14, and we keep the 5 and the 10. You get negative 7 times 10 is negative 70, minus a negative 70, that becomes plus a 70, and that is also 0. N sub y. Now we go back to our x's being there. Now we sub in for the y. And again, when you multiply these and you do the determinant, so 8 times negative 14, and then minus 7 times 16 times negative 7, you end up with 0 again. So what happens is you get x is equal to 0 over 0. What this means is, first of all, this would be undefined, but if it's a 0 on top and bottom, these mean all points on the line. This is that situation where you have 0 equals 0. It's true when we did systems. So all points on line are a solution. So when you have 0 over 0 for both, that means that you have all points on the line. If I had like 5 over 0 and 7 over 0, that statement would, think of it as a statement, are they equal? No. Those would be no solution then. So that is how you know if it's all points on a line or no solution. No solution again would be something like this: x equals 5 over 0, y equals negative 3 over 0. These would be no solution. But if it's 0 over 0, all points on a line. Okay, that's number 2. Let's do a word problem. Suppose that your family is going to buy a new air conditioning unit. One brand costs $1,800 to buy and $60 a month to operate. A more expensive brand costs $2,600 to buy, but it is more efficient and costs only $50 a month to operate. Let M number equal the number of months since you purchased the unit. Let the cost be the cheaper model, C of M, and E of M be the more expensive model. So let's write our particular equations expressing both of these. So I have C of M, the cost of the cheaper one. The slope is how much it is per month. Remember, when you're writing a word problem out, the slope is the thing that's changing per month. So this would be $60 times M, plus we started by buying it for $1,800. The more expensive model has a slope of only $50 per month, but we started off with $2,600 to buy it. So those are my two equations. So then we say find C of 100 and E of 100. So we're going to basically find the cost of each of these when the month is 100. So C of 100, when you plug in 100, you get 6,000 plus 1,800, you get 7,800. And E of 100, you get 5,000 plus 2,600, you get 7,600. And what do these numbers tell you about the relative cost? Well, notice how the expensive model is now cheaper. So the longer you have the air conditioner, the expensive one becomes the cheaper one. It already has happened for us, right? As you started off, you spent more money on the more expensive one, but as you run them both, as time goes on, that expensive model will actually catch up because you're saving $10 a month, and finally it will surpass it and become the cheaper model. Solve the system of equations in part A to find a break-even point. Sketch the graph. Well, the break-even point would be when they're equal. So all you have to do is say that C of M and E of M are equal and just set the two equations equal to each other. You want to know when the cost equals the same thing for both. So when you solve this, you subtract 50M, subtract 1,800, which is 800 left. So M is equal to 80. So at month 80, they cost the same. So anytime, if you have the air conditioner longer than 80 months, then it works fine. Then the expensive model is actually the way to go because it becomes the cheaper model. Because now it's cheaper as you go than the cheap one because it costs more to run that thing. Sketch the graph. Alright, so the two graphs would be something like this. I'm just going to say the starting point is 1,800. This starting point is 2,600. This has a higher slope than this one has a lower slope. And then this is the break-even point. And I'm going to say this point is 80 months. So this is 80. This is months. And this is the cost. 80 comma 6006. Oh, how do I get that 6600? You figure out how much it costs to run each of those at that point. So I just said, okay, C of 80 is equal to 60 times 80 plus the 1800. So both models will end up costing you $6,600 if you run them for 80 months, which is the break-even point. Alright, pretty easy, setting them equal. Okay, this one you guys can do for review, just try it out, and we'll go over that in class. And you guys, thanks for stopping by, and stay classy.